Hello, everybody. Are you having fun? Yeah. Are you having fun? Yeah. As one of the organizers of this conference, I hope that you will learn a lot and have fun. But before I start my talk, I want to tell you something hypothetically that never happened to you. A story. So your manager comes to you and gives you this kind of design that the designer in your company just did to your website. Yeah, hypothetically, those things never happen when we are creating applications. And then the manager says to you something like, hey, you're responsible for this thing in the web page, and you should create that part of the web page. Hypothetically, never happened to anybody here. So what you are going to do right now is probably start to take that design and break it into your implementation. So if we're talking about the previous web page, we have a movie section, and each movie has a title, a search, movie list, and we can take a look at this part as components. We have a big component, a smart component, like Jesse said in his talk before me, and a lot of dumb component, child components that correlate with the data that the smart component sends them. But we can think about those components as just HTML. Wouldn't it be nice? Yes, it would, but we're web developers. So the next decision that we're going to take is, boom, we're going to create this web page with Vue, Angular, whatever, or React, or any other framework. Do we really need those libraries and frameworks to build this entire component? What if I tell you that the browser can create its own components, native components, if you just tell him how to do that? And this is where our story begins, and this is what this talk is all about. So the agenda of this talk is the following. We'll talk about Web Components API, a native way to create components in the browsers. And then we'll talk about Angular Elements, which takes those Web Components idea and gives you the opportunity to create Angular components as web components. So what is the Web Component API, or the standard? So the W3C, or the World Wide Web Conservatorium, created a new standard that helps you to create your own components. Not with Angular, not with React, not with Vue, not with everything, but rather as standalone components that the browser knows how to use. Those components have, or should have, things that are best practices, like, semantics and encapsulation and separation of concerns, and et cetera, et cetera, et cetera. These things the standard group tried to figure out how to create. So they end up with 4 different standards. The first one is template. What is a template? It's just a DOM fragment that you can create, and then create instances from that DOM fragment. Okay? Whoever used JS render or handlebars or underscore, you used those things in the past, same as using templates today. The second standard part is the ES models. ES models enables you to load JavaScript models that you export from files to your browser. That's it. Okay? So this helps you to lift up a lot of the things that bundlers do today, if you want to use that kind of API. The third part of the standard is Shadow DOM. And Shadow DOM enables you to encapsulate some part of your DOM, and custom elements enables you to create your own elements, native elements in the browser. And this is what we are going to talk about in the next 25 minutes. So what are custom elements? Again, as I said, you can create native elements in your browser. How you do that? Either you extend HTML element, the generic HTML element, and get all the properties from that object, or you extend existing elements, like, for example, if I want to extend the input type. Then I can extend HTML input element. And then after I create the class for the element, I just register it in the custom elements registry. The custom element registry lives in the window object, and you just use the define function with the name of the element, and you create your own elements. So with that, let's start with our first demo for today, which is let's create a custom element. At first, what I'm going to do is I'm going to create a string. This is going to be my template for the entire component that I'm creating. That component is going to create a collapsible panel, a simple collapsible panel. It will get injected with its content using the slot element. The slot element is relevant from the template, from the templates themselves, and they enables you to use slots. And if you are coming from an Angular background and you are in an Angular conference, then ng content, if you use that, it's the same thing, okay? So this is the slot. Then the second thing I'm going to do is I'm going to create a class. That class is going to extend the HTML element, okay? And in its constructor, it's going to call the init function. What is this init function? Here I'm doing a lot of heavy lifting. First of all, I'm creating a shadow boundary, a shadow root from my component. I can do that using the attach shadow function that exists on every HTML element, okay? And I can create that with two different modes. Open, which means that on my element, there will be a shadow root property that I can use to query things inside my shadow DOM. Or the second mode is closed, meaning that the entire content of this element is encapsulated and you can't do anything from within if you want that. Then I create a new element, a template element, and I inject the HTML from here to that template and create an instance from it. Okay, template.content clone node. This function on the in the template API enables me to create instance of that template. Then I'm querying the header from the template. Here is the header, and I'm putting it as a property inside my component. I'll use it later. And I'm appending the entire instance to my shadow root. Last but not least, I'm creating the show, which means this part is going to be shown by the collapsible panel, true or false, and I'm hooking a bound collapse function. Let's create a few things in this component. Like Angular, the web component API declares a lot of lifecycle events that you can use. One of those is connected callback. Once the element is connected to the DOM, then this callback would be called. And in this callback, I can do things. For example, what I'm doing is grabbing the attribute, which is data-title, and I'm wiring to an event listener to the bound collapse function. Another thing that I'm doing is just putting the content element inside my object once it's in the DOM. We have the connected callback. We have the disconnected callback. Once the element is disconnected from the DOM, then do things like, for example, what my mother always tells me, Gil, clean after yourself. And this is where we remove the event listener, for example, the click for the bound collapse. Let's create the bound collapse. This function is easy. I'm toggling between the show, not show, and I'm checking if I'm currently shown, then my display is blocked, otherwise none. Okay? Now I have my entire custom element created. Last but not least, very relevant once you created the custom elements is to register it in the registry. One of the famous questions in Stack Overflow, I created a fancy custom element and nothing works. Oh well, the first answer will be, did you use the define function? Let's use it. window.customElement, define collapsible panel with the implementation of our collapsible panel. That's it. Now I can run the web page here, which uses this collapsible panel. You can see it here, with data title collapse me and what's injected into the slot. Let's run it. First demo. Open in the browser and yay, we have a collapsible panel. Woo! So we have a collapsible panel. We saw how we create those custom elements. This is the API. Let's move on. Let's talk about a problem. A problem that I call it the Catholic wedding problem, okay? In our world, once we start creating applications, web applications, we have a decision to make. Either we pick Angular or React or Vue or whatever. And that's a good decision. It's a smart decision, and we pick those frameworks and libraries, and that's okay. But, here's a big but. What happens if our entire infrastructure is based on React, Angular, Vue, or whatever? Here is a story, real-world story from one of my clients. One of my clients came to me and asked me, we have a problem, Gil. We have a React application that one team created, and we have a Polymer application that the second team created. And our manager asked us to combine a few components from this application and for a few components from that application into a third application. How can we do that? How would you do that? Not a very happy thing to do, but in the end, they created the entire thing again, the entire components again, but this time the entire application was React application, and they ditched the Polymer application that they had. Okay, 3 years of creating an application with Polymer went to the drain. Another real-world story. A company that I consulted for acquired a different company, a startup. That startup had a big application written in Angular 5, and the company that acquired them had a big application written in AngularJS. When I say big, it's like 5 million or 6 million lines of code written in JavaScript or TypeScript, etc. Okay? So they came to me and they said to me, Gil, our manager asked us to combine the two applications, the two dashboards, into one dashboard, and they want it in 1 month. So how can we do that? I said to them, good luck. So the solution was we created iframes to consume both of the application and a meta router to coordinate the states between the two applications. It took 3 weeks, and then they started to migrate the entire AngularJS application, and that took them 9 months. Not fun. So what can we do in order to tackle this problem, this Catholic wedding problem? If we can use, for example, some other way for our infrastructure, for example, custom element, would it be better? So again, as I said, custom elements are native elements in your browser. That means that they can be consumed by any kind of library and framework. Angular knows how to use custom elements. React knows how to use custom elements. Vue knows how to use custom elements. And all the frameworks knows how to use custom elements in the end, because they are part of the browser once they are defined. Okay? So we can encapsulate our JavaScript style for infrastructure components with custom elements. Cool. But there are problems with custom elements. First of all, we are the problem. As developers, we are used to things like reactivity, data binding, performance, and as you saw in the custom element demo that I did, I had to craft everything by my hand. All the data binding, all the performance tuning, if I want a virtual DOM, I need to create that for myself, etc. Second problem, too much boilerplate. I need to do a lot of development in order to create custom elements. And I need to do it by myself. As a developer, that's fun for me. I love creating a lot of things and write code. But for your managers, that's a bit of a tricky thing. Last but not least, not all the browser has the implementation of the standard built in. Most of them have, but you see the right side. So you have to use polyfills, a library that will gap that non-existing functionality if you want to target Edge or Internet Explorer. Okay, so this is another problem. So can we do better? And can we combine custom elements and web components with Angular? So Rob already did the introduction to Angular elements in the morning in his keynote. But Angular elements is taking that step and delivering you the ability to create custom elements or use the web component standard as is, but with Angular. What I mean is how it works. So in a regular environment of custom elements, what the application is doing is registering the custom element in the custom element registry. And once the custom element is added to the DOM, then an instance of that component is created. That's cool. And that instance knows how to handle things if you created that functionality. For example, data binding or things like that. What Angular Elements is giving you is the ability to create your component as an Angular component, create that component as a custom element using the create custom element function, and then you just define that element as is. And Angular will do the whole heavy lifting of all the features that you are searching for, change detection, data binding, etc., for you. So let's take a look at how that will work in an Angular application. Whoa, Visual Studio. Oh my God, Visual Studio is opening right now. It will take 10 minutes. Okay, so here I am in an Angular application, okay? And let's create the same collapsible panel that I created earlier with custom elements, but this time in Angular. So I have an input that gets the title, I have a collapsed member, and a toggle function that does collapse and not collapse, and etc. And I have my HTML here. Let's do that. Here is the HTML for that collapsible panel. Again, with the Angular syntax, this time I'm using ng content instead of slot, and I'm binding to the click event to toggle all the things, and the title is I get it as an input. Now I want to use that component in my application. So I can do that, of course, but I want to create it as a Angular element. So the first thing that I already did, because I don't want to wait for npm, is install the Angular-element library, okay, or module. Okay, you go, you do npm install at Angular/elements, and you have Angular elements in hand. Then you just need to do the following. Let's do it. I have here the application components. And in my constructor, I can get the injector. And I'm saying something like that. Create custom element. That function comes from Angular element library or module. I'm giving that the collapsible panel component and the injector of my application. Then I just register that component that I got, that custom element, in the custom element registry, using the same define function that you saw earlier. Now, but now you have an Angular component that is used as a custom element. Now I can run this application using ng-serve, and everything should work as expected. I will have my collapsible panel, okay? But this time, this collapsible panel is not a custom element that I created, but rather Angular created for me all the implementation, and it was wrapped in my custom element. Angular element wraps the entire Angular element, or sorry, should I say component, as a custom element, and you can use it as is. But this is the time that you say, but why to bother? You remember the Catholic wedding that I talked with you earlier? That thing? Then I want divorce. Not from my wife, but I want to divorce from those frameworks and libraries. And what I mean by that is, once you need to create shared components between applications, for example, if you have a micro apps environment, then Angular elements can be very helpful for you to create custom elements that can be consumed by any of the elements, and you get the gain of using all the set of skills that you already have from Angular wrapped up as custom elements. As Rob said in the morning, if you want to create a design system, yeah, who haven't created an input type again and again and again in his company? Or a button with some fancy design. You did that. Yes. Raise your hand if you did that. If you're not raising your hand, you are lying to yourself. So we are creating design systems, but those design systems are mainly created using the framework that we use, that we know and we love. But if you can create those design systems as custom elements, then you will be able to reuse those in your applications, and you will be able to ship those to everybody else to consume outside of your company if you want to create some open source library. For example, if you've been to Mike's talk, Ionic 4 is built on top of Stencil generated components. Stencil is a compiler that generates custom elements. So the entire Ionic core was created as custom elements. Yes. And if you're using Ionic 4, then you're using already custom elements in your applications. So let's summarize. Web Component API are a very powerful standard. They can give you a lot of goodies, creating a native elements, a native HTML elements in your application. But it quirks a little bit. We are used to things like all the good stuff from frameworks, and we need sometimes polyfills if you're directing into an Internet Explorer, Edge, or whatever. So you can still use those with polyfills, and in Angular world, you can use or heavy lift the entire thing, entire custom elements, by using your own knowledge of Angular. Create your component, define a custom component from this component, from this Angular custom component, and you are ready to go. You are not tangled into Angular. And I know from talk with the Angular team that they are working very hard on Ivy and to minimize the size of Angular when you are using Angular elements. Because currently the drawback of using Angular elements is the size of the runtime of Angular that comes with it. Okay, so they are doing a lot of work to minimize everything, and this is something that you can use already today. Angular elements exist for 1.5 years already, so you can use that even today. If you want to read about Angular elements, go to AngularIO guide elements. Of course, if you want to read about custom elements, MDN is the place to go and search for things. You can follow me on Twitter. I'm very responsive. If you're asking questions, I try to help you and answer, even if the answer is I don't know. It's okay not to know everything. But with that, I want to finish with this thing. Web components are here to stay, so use the web platform look. Thank you.